Have you ever wondered how atoms interact with each other to form various compounds? Well, everything hinges on a concept known as valency. This is the combining capacity of an atom, a measure of its ability to bond with other atoms. It's like a dance card, dictating who gets to tango with whom in the atomic world. Now, this dance card is determined by the number of electrons in the outermost shell of an atom. You see, atoms are a bit like social butterflies, always striving for a full outer shell, and they'll bond with other atoms to achieve this. Understanding valency is akin to understanding the social dynamics of atoms. It's a key that unlocks the door to predicting how elements will bond with each other. Now that we have a basic understanding of what valency is, let's dive deeper into the valency of the first 20 elements in the periodic table. This journey promises to be as exciting as it is enlightening. Starting from the very beginning, we have hydrogen with a valency of 1. Hydrogen is a social atom, typically forming one bond with other elements to achieve stability. Then there's helium, the party pooper of the group, with a valency of 0. As a noble gas, it's quite content and doesn't often engage in bonding with other elements. Next up, we have lithium. Just like hydrogen, lithium has a valency of 1. It's quite eager to lose 1 electron and achieve a stable configuration. Then we have beryllium with a valency of 2. It's a little more ambitious than lithium, commonly losing 2 electrons to achieve stability. Coming up next is boron. Boron finds its stability by forming 3 bonds with other elements, giving it a valency of 3. Then we have carbon, the social butterfly of the periodic table, with a valency of 4. Carbon achieves stability by forming 4 covalent bonds with other elements. Up next is nitrogen, a bit unpredictable with a valency of either 3 or 5. Depending on the situation, nitrogen can form 3 or 5 bonds. Then we have oxygen with a valency of 2. Oxygen likes to form 2 covalent bonds with other elements, making it pretty predictable. Next in line is fluorine with a valency of 1. Fluorine completes its octet by forming 1 bond, just like hydrogen and lithium. And finally, we have neon, another noble gas like helium, with a valency of 0. It typically does not form bonds with other elements. So there you have it, the valency of the first 10 elements. Each element's valency is determined by the number of electrons it wants to gain, lose, or share to achieve a stable electron configuration. It's like a glimpse into the social life of atoms, isn't it? That covers our first 10 elements. Now let's move on to the next 10. Moving forward, we have sodium, also with a valency of 1. It's just like the life of the party, always ready to lose an electron and get things started. Magnesium, on the other hand, is a bit more generous, commonly losing 2 electrons, achieving a valency of 2. Next, we head over to aluminum, often forming 3 bonds with other elements, leading to a valency of 3. It's like that friend who's always ready to lend a hand, or in this case, 3. Then there's silicon, the backbone of our modern digital world, which usually forms 4 covalent bonds, resulting in a valency of 4. Now, here's where things get a bit spicy. Phosphorus can either form 3 or 5 bonds, depending on the circumstances. It's a bit like a chameleon, adapting to the situation at hand. Sulfur, too, can either form 2 or 6 bonds, again, depending on the circumstances. Sulfur is like the wild card of the group. You never know what you're going to get. Next up, we have chlorine, commonly forming 1 bond, completing its octet. It's the minimalist of the group, always keeping things simple. Then we have argon, another noble gas, usually not forming bonds. It's like that independent soul who likes to keep to itself. Almost there, folks. We have potassium, tending to lose 1 electron, resulting in a valency of 1. It's like sodium's partner in crime, always ready to join the party. And finally, we have calcium, commonly losing 2 electrons, achieving a valency of 2. So there you have it. From sodium to calcium, each of these elements has its unique way of interacting with others. Some are generous, ready to give away electrons. Others are adaptable, changing their bonding patterns depending on the situation. And some prefer to keep to themselves, not forming bonds at all. And that's the valency of the first 20 elements in the periodic table. So, to recap, we've learned that the valency of an element is determined by its outermost electrons. This wonderful world of atoms, from hydrogen to calcium, each possesses unique valencies, shaping their behavior and interactions. It's this valency that predicts how elements bond, whether it's hydrogen with a valency of 1 or neon with none. Understanding these interactions is vital, as it's at the heart of every chemical reaction. Remember, understanding valency is a key step in mastering chemistry. Thank you for joining today's exploration into the world of atoms. Stay curious and keep exploring.